unmute
yes,
your...
it's ready.
Yes,
sorry.
Yes, we can hear you now.
Thank you
please.
so much. Do you
Thank
see my presentation or not?
Yes, we can see you.
Thank you so much, ladies and gentlemen. Thank you for inviting me to participate in the conference. Special thanks go to Professor Alper Baba, with whom I have been collaborating for several years. Following to the main topic of the workshop, geothermal energy for sustainable development, it should be pointed that both aspects of geothermal sources are most important, water and energy. However, the use of these resources on a global scale is best now for the direct electricity generation and also indirect binary system in the district heating and domestic hot water distribution, and the use of geothermal water in balneology and recreation. But it also should be pointed that geothermal water energy are vital resources needed to resolve critical issues to building a sustainable and desirable economy, improving life conditions, health, and to avoid hunger in many parts of the world. These aspects are directly related to United Nations Agenda for Sustainable Development and its goals, especially clean water and sanitation, sustainable and modern energy, climate change, and its impacts. This is why, by the UNESCO Chair on Groundwater with the Agenda for Sustainable Development, some aspects of arsenic mitigation using geothermal water energy have been analyzed for several places in Latin America. In the present work realized by international team, the use of low enthalpy and waste geothermal energy in freshwater production were analyzed for the 3 regions: Cerro Pietro in Mexico, Momotombo in Nicaragua, Lake Popo in Bolivia. As it was presented due to the considerable heat demand of the distillation process, in the future, this solution is most likely to be used in areas where cheap sources of heat are available. However, it's not just geothermal energy, but also geothermal water that can be considered a solution for obtaining water and good quality, depending on mineralization values, temperature, water yield, and other parameters of the geothermal water. Different options can be suited according to the characteristics of different locations worldwide. What is more, worldwide there have been millions of oil and gas wells, many drilled deep zones where temperatures are presses high, often producing hot water together with hydrocarbons. That is why also in wells with current oil and gas exploitation, where co-produced hot water can be used as geothermal, and it's also under consideration, and abandoned oil and gas wells that can become a source for using heat directly, for example, mentioned membrane distillation water treatment. It should be also pointed that in many geothermal international projects, some critical aspects are under consideration during evaluation in different countries, especially geothermal energy, basis for low emission space heating, improving health conditions and sustainable development. Development of enhanced geothermal system technology using supercritical CO2 as working fluid, reduction of CO2 emission by carbon capture and storage, CO2 emission mitigation strategy with hot dry rocks, and enhanced geothermal systems. So this is why in many countries, the geothermal conditions in different countries are updated of geological and geothermal resources conditions exploitation parameters are evaluated, especially also hydrogeological, hydrochemical, geothermal parameters, and estimation of geothermal resources with selected hydrogeothermal structure. recognition of geothermal condition for crystalline massive, for hard hydraulics and enhanced geothermal system, and many other topics related directly to geothermal energy. However, improved geothermal use, the main topics are also physical, chemical geothermal water quality recognition and advanced methods used for geothermal water energy management. Development of water treatment system and the combination of geothermal energy and desalination processes, emerging microelements capturing recovery from geothermal water from, for example, lithium, what is most important nowadays. In the context of water desalination, both aspects, electricity and heat production, are considered. However, because high enthalpy geothermal resources are very limited, that is why low enthalpy geothermal resources are much more analyzed, especially low temperature shallow geothermal aquifers, geothermal springs, hot water separated from hydrocarbon fields, water discharge from underground mines, rest heat from different processes also for geothermal power plants. Geothermal waters present in geothermal structures may be fresh water and water with low mineral content, as well as brine with mineral content exceeding 100 grams per liter. In terms of the amount of water mineralization, the water question can be divided into 4 groups: brine water, saline water, brackish water, fresh water. Since these waters usually exhibit increased concentration, several ions, chloride ions, sodium sulfates, calcium and magnesium, iron, iodine, and also fluorine, boron, arsenic, and in many places also high concentration of lithium. In case of increased concentration of hydrogen sulfide, they also use for therapeutic and biological purposes as well in many places of the world. The local occurring worldwide high salinity of geothermal waters allowed to undertake research work aimed to generating energy from the salinity gradient also, what is more and more interesting nowadays. Such topic was a research idea of our bilateral Polish-Turkish project, Geothermal, integrated management of geothermal water, recovery energy and water. It was realized by Wrocław University of Technology, AGH University of Science and Technology, and Ege University in Izmir, and special thanks for Professor Nalanka Bai, with whom I also collaborating from several years, and the topic was realized in this team. Nowadays, energy extraction from high mineralized geothermal water can be possible using reverse electrodialysis and capacity mixing, and processes which was analyzed in our geothermal projects. Both solutions involve innovative technological processes. One should be noted also that the concept for energy harvesting from the salinity gradient on the basis of geothermal water refers to the use of waste geothermal water cooled in classical geothermal systems or electricity generation or heat production. And it was also pointed that on what is presented on the figure on the left, the different options with theoretical calculated available energy extraction by mixing 1 cubic meter of high saline solution and 1 cubic meter of low mineralized water can produce a special electricity amount. The design of the reverse electrolysis and cap mix, which was analyzed in our project unit, can in future work as a concentration gradient. Flow battery as in the present on the right figure. The reverse electrodialysis mode is one of the solutions to operate renewable energy and may play a storage device. And I think in the future can be really interesting for the application. However, it needs some works, of course. According to our project results, the table presents the calculation of the net electrical power and energy production in different cases of geothermal water mineralization, a case of Polish experiments. It could be pointed that in the case of high geothermal water salinity, about 140 grams per liter, energy production based on water flow 10 cubic meter per hour is really promising. It's equal to 6.4 megawatt hour per year. However, of course, it should be evaluated in future, and also we are working on the result from the Turkish side about to use reverse electrodialysis experiments to the net electrical power and energy production. The next topic of geothermal water and energy utilization is the second our bilateral project, Water Energy Food Nexus, Geothermal Water for Agriculture. The acronym is GEO for Food, and is realized by AGH University of Science and Technology, ISMI Institute of Technology, Wrocław University of Technology, Ege University, and special thanks to Professor Alper Baba and Professor Naranka Ban, who are main scientists in our company and our collaboration. It's really interesting project connected with the water treatment, geothermal water treatment processes, and also use of energy from geothermal sources, and also connected with solar energy, biogas production, to solve the problem of food and sustainable use both sources to agro-food industry. In case of Polish team, the research is realized in our geothermal laboratory of the Mineral Energy Economy Research Institute of the Polish Academy of Sciences in Bajska Niżna. It's a part of Poland. Here, it should be pointed that first geothermal plant in Poland was constructed and put into operation in the Podhale basin in 1993. The cascade heat supply include 5 stages of heat distribution based upon a secondary circulation loop. The first step provides hot water for district heating for apartments and buildings, and hot water for domestic uses. After the first thermal utilization, the water had a temperature about 60-65 degrees Celsius, which was enough for a timber drying building. The next step include the parapet greenhouse, a fish farm for thermophilus fish for temperature about 35 degrees Celsius, and the final steps provide ground heat for polytunnels. This arrangement permits studies to be carried out on the multidirectional development of geothermal energy. So in our laboratory geothermal laboratory, the first geothermal water treatment project has also been developed. The study assessed the potential of the use of membrane technologies to reduce geothermal water mineralization and enhance removal of boron and other microelements such as iron, fluoride, arsenic, so making geothermal water suitable for discharge into surface waters or used for drinking and space heating purposes. Waters from different geothermal fields in Poland were tested here with different mineralization and microelements. And now we use this system for water production in our Go4Food projects for irrigation of food lettuce cultivation. Here is a sketch of the system, and for the geothermal water treatment, here membrane technology were selected on the basis of the ultrafiltration, reverse osmosis, and the desalination process was carried out with a typical industrial plant component and include water pretreatment facility, mechanical filter, iron remover unit, and ultrafiltration module. The second two-stage reverse osmosis setup, which can be also use nanofiltration processes connected in series, this part. And the third, final treatment, mineralization, disinfection to achieve the requirements values of the drinking or irrigation water parameters. The pilot facility was fitted, as I said, with typical industrial plant components, and it works and continuous cycle. Capacity was expected to be 1 cubic meter per hour of desalinated water production, and low pressure of about 1 megapascal was used at the reverse osmosing both cell to receive high quality water. And some pictures from our project from Geo4Food, where nowadays in our laboratory is realized some experiments for greenhouse lettuce cultivation using geothermal energy and greenhouse heating and treated geothermal water for irrigation. The methodology experiment, the first step is preparation of the seedings and the water treatment installation, adjusting the desalination plant, treating geothermal water. Next, planting the seedings and preparing 3 types of mixed water, which is used for irrigation, measurement and maintenance, and physical and chemical analysis of water, soil, and also food, lettuce. And here is some pictures presented for the 2 different methods of cultivation. It's a hydroponic and soil cultivation realized with 3 different water. A mix of 100 treated geothermal water with nutrients, mix of 90% treated geothermal water and 10% of raw geothermal water with nutrients, and mix of 70% treated geothermal water and 30% tap water, which is used to irrigation. Here is the first week of hydroponic experiment. After one first week, they use this water in different purposes. The next slide, it's present the hydroponic experiment after 3rd week. It's our lettuce growing, so it's really nice, and the special after 6 weeks, our hydroponic experiment, we receive really high quality lettuce, and after realize the analysis in laboratory, accredited laboratory of both water and lettuce, we receive very interesting results for different 5 kind of lettuce, and quality of it was really good. And the second experiment with soil and also some pictures after first week of experiment, third and fifth. We also receive really high quality of the lettuce, and all this lettuce goes to the was analyzed by the laboratory and show that the high quality and fast increase by the process. And also during the experiment, we cultivated eggplants, zucchini, and tomatoes. Both geothermal water energy use energy for heating of greenhouse and water for irrigation during our experiments. So, as it was presented, our laboratory is located in the south part of Poland, and here is the map of the Podhale geothermal basin. This really small part of the country with the best condition of geothermal energy exploitation. In that region since 1994, the biggest geothermal district heating project in the country have been underway. Reservoir temperature reach up to 90 degrees of Celsius, and the maximum flow rates vary from 50 to 150 liters per second of the water temperature 80 to 86. The water mineralization is really interesting and generally low, and it's not more about 2.67 gram per liter. And nowadays, about 2,000 receivers were connected to the geothermal heating grid, individual houses, multifamily buildings, hotels, boarding houses, schools, and other buildings also. Recreation places with bathing centers. In case of Polish side, geothermal water energy resources in Poland are also associated with the formation of various ages in the Polish lowland, especially Lower Jurassic and Lower Cretaceous. And it's on the map is presented the border of the structure. And space heating, that is why, because it's a low enthalpy geothermal resources, space heating is a key sector for the geothermal energy industry. And it is also worth noting growing just a recreation and balneology, which has been demonstrated by the sum of old spas. It's an example of the oldest and the best known spa facility from 17th century in Lądek-Zdrój, in the south west part of Poland, near German border. And also new recreation centers, which is opened in recent years, with example from the South Poland, from the geothermal basin of the Podhale system in Bukowina Taczańska. So, because I was invited to your conference, it's really nice, and thank you so much. And I also would like to invite you to Krakow, where I'm working here. Very beautiful old city with Wieliczka salt mine and also Royal City Krakow. So I hope it would be possible after COVID. And finally, I would like to thank you very much for your attention. I think that our collaboration is very strong, and I'm very glad to say that if we have hot research topics, realize hot research topics, and we have really good success in publishing. And I hope realize next interesting projects in geothermal system. Thank you so much.
Thank you very much, Professor. Now we will pass to questions. If you have participant any questions, you can submit your questions in the question and answer panel. So I would like to ask you a question, Professor. In your geothermal project, when you are extracting the energy from the salinity environment, is there any optimum or limitations in this project that you observed?
Yes, we think that is really necessary to work more and more about the problem with membrane and different system, because cap mix is a first step of the evaluation of the possibility to receive energy from the salinity gradient. However, red system is under realization, for example, in Netherlands. So if you ask me about the limitation, I think it's something like the photovoltaic 30 years ago. We saw that it was about first steps, but I feel that maybe because of the increase of technological aspects, nanotechnology, the membrane systems, I think especially reverse electrodialysis can obtain real interesting level. Maybe for 10 years we will thought about the implementation to the industry, maybe 20 years, but it's promising that apart from the experiments on the seawater, mixing seawater and fresh water. Seawater is lower, has a lower mineralization than in many cases geothermal water. So I think it was our initiative to make experiments on mixing geothermal high brine water and concentrates from geothermal water treatment. It was interesting and showed that both processes are interesting. However, we have to work on the improvement.
Thank you very much. Thank you very much, Barbara, for your answer. So now we will pass to the our second presentation. So our second presentation will be performed by Dr. Elif Pazvantoğlu. So I would like to kindly ask to her to share her screen. And the title of her presentation is Surface Heat Flow in Western Anatolia, Turkey, and implications to the thermal structure of the Gediz Graben. So, Dr. Elif, the floor is yours. If you could share your screen.
Good morning, everybody.
Yes, I think Professor Barbara should close her screen, and then you can share your screen.
Sorry, I'm trying. I can't do it. I can't do it. I'm not. I don't know how to do it.
I think on the bottom side in your share screen, if you click again, you will close your share screen.
I'm clicking.
Yes, click again, or it could be on the top side also.
Stop sharing. I generally use other systems, and I don't know why I pause sharing, stop sharing. Stop share. Yes, thank you.
Thank you very much. Thank you very
Sorry.
much. So now you can share.